Hello everyone. Today we're going to implement a Python program that can detect objects on an image using YOLOv3. And here is the official website. We're going to be using computer OpenCV to use this network, and we can download weights and configurations of YOLOv3 from this website, which is an official website of the author. Also, we will need some since this model has been trained on Coco dataset, we're going to need Coco names of the classes. So I'm just gonna copy this. I'm going to create the txt file called Coco names and just paste all the Coco classes in there inside of this folder. So now we have this Coco names here. Okay. Yeah, and we can start by importing some of the libraries that we are going to use. We're only going to use two libraries. One of them is OpenCV, which is necessary for loading the model and for showing the images and basically for doing anything. And we are also going to need NumPy. I think that's all we need. Let me see what is the module named. Oh, we can just install them. All right, so we can start our project. First things first, there is this function that was added recently. We can use this new functionality to to load basically neural networks. And now we're going to load the YOLOv3 that we downloaded from this website. Yeah, you can also choose which one you want to download. So this one is slow. No, this one is, I think, pretty fast. And this one is the fastest because it's tiny and the size of the network is smaller, and it can run good on maybe Raspberry Pi and some slow computers. And yeah, you can choose, like, looking at the FPS here and looking at the flops, like how much computation it requires. You can see this one requires less computation power, this one requires a little bit more, and this one is the most heavy to compute, so I mean to run. So you can choose the one that you want. And all right, so let's move on to the weights. We have chosen this version, the one that is lightest among these three, but a little bit heavier than Tiny, which I'm not sure how it's gonna be. Cut it later. Okay, YOLOv3. YOLOv3. Oh, I forgot V here. Okay, YOLOv3 weights and YOLOv3 configuration file, CFG. Oops. And what do we need? So after we load this thing, we also need classes, which is an array. But remember how we just copy pasted all those like Coco names in here? So we can just use a little bit of Python to read whatever is in there. So with we just open the file. Coco names.txt. Yeah, open it as just reading. R stands for reading. And as a file called F. Okay, so now that we open this file, we just gonna make classes, same as same as every line in. Sorry, I'm kind of bad at typing, so I keep looking at my keyboard when I type. Maybe I should get better at better at typing. For line in f dot read lines. Yeah, so basically what it's gonna do is it's gonna open this file. It's gonna read lines. So split the file into lines, those little lines here. So, and for each line, it's gonna strip all the white parts. So like white space, maybe new line characters, and it's gonna put them all into this array. So now classes array contains all the classes from the Cocoa dataset. And since the model was trained on Cocoa, it's okay. So, okay, so how do we get layer names? Is we just get the network that we defined before in here. And we are going to get layer names. So after we get the layer names, output should be array. Yeah, should be an array. Should be layer names. Zero minus 1. Yeah, okay. Now we need an image that we can use for detection. Let's see. You can go to Pixabay, and here you can download images that don't have any copyright file. And yeah, if you download low quality image, then it's gonna be free. Yeah, so you don't have to pay anything. And we're just gonna rename it as image. Yeah, just image.jpg. I think it's fine. Okay, let's go back here. Now that we have our image, we can just load the image. I'm just gonna use a CV2 native function read to read the images. Back. Oops. And then we need to get the dimensions of the image. So now the image has its height, width, and also depth, which is like 3 colors, right? RGB. So we need to get those values, like how big it is, and I mean how wide, how tall, how wide, and how deep the image is. mg.g. We need to So first we convert the image into a blob, which is an appropriate input into the network. And then we input that blob into the network using set input. And then we receive outputs of the network from its output layer using the forward function. Then we will implement a part of the function that will be responsible for displaying the images. Oh my god, look at me, I'm so tired. Oh man.
So the next thing we're going to do is to sort out detections based on the confidence. So what confidence is a probability that we get from the output layer of the network that an object is detected. So for example, if in the image there is a phone, and in that rectangle, network sees a phone, it's gonna mathematically calculate what's the probability that those set of pixels is actually a phone. So if it's more likely that it's a phone, then the confidence is going to be high.
When YOLO detects an object, so how YOLO works is that it looks once. So the name of the neural network is called YOLO because it's like you only look once. So basically what it does, it looks at the image once and then creates lots of detections in one go. So let's say that in an image there's a bottle and a ball and a face, then it's just going to take this entire image and do all of the detections at once. How to say that? It's gonna it has this concept of boxes that are likely to be an object. For example, like maybe boxes that are a little bit long, maybe to detect a bottle or maybe to detect a human that's walking like this. Yeah, and if it's a ball, then there are some rectangle sizes that are this size, right? So what YOLO does is that it takes the image and then draws lots of rectangles like this, the ones that are predefined beforehand that have high chance of occurring, and then it it calculates the probability that the object is actually inside of that rectangle. So for example, let's say it draws lots of rectangles that are long like this. Yeah, and it's gonna just draw lots of rectangles in this way. And let's say the bottle is here, right? So it's gonna draw lots of rectangles here, 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 here. Okay, let me hold it here. It's gonna draw a rectangle here, 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 and there's nothing there. And then once it draws a rectangle that's long in here, like it sees there's a bottle. So the probability that the object is actually in this side is high. Yeah, but how to say it? Maybe it will give like high probability, maybe 99% confidence that the object is actually here, but it will also draw rectangles maybe here or here or here or here, somewhere near it. And we don't want that. Like we just want the rectangle that is around the bottle and has the highest probability. And we don't want the rectangles that are drawn like this and maybe have 70 probability. We want the one that's like 90 and only covers this bottle itself. So what non-maximum suppression algorithm does is that it takes that bounding boxes that are close to each other. And then if this one has like 99% probability, and then there's another bounding box that has, I don't know, 80% probability and is right next to it like this, then it's gonna, as its name suggests, non-maximum suppression, it's gonna suppress everything that's not maximum. So in this case, 99 is a maximum. So it's gonna suppress this bounding box and just leave the one that's 99. So we are going to add that method to our program. Thankfully, computer vision, OpenCV has this thing implemented. It's called NMS boxes, non-maximum suppression boxes. And yeah, we don't have to implement it ourselves. We can just call a function just like that.
And the rest of the code is not very important because it's mainly responsible for just drawing the rectangles and annotating those rectangles around the detection. And then, as it always happens, there are some typos and there are some mistakes. And I think while talking, I made quite lots of typos that I need to fix. Oh my God, I'm a terrible programmer. One important thing in here is that your image need to be of size of multiple of 32. So basically the height needs to be a multiple of 32 and the width needs to be a multiple of 32. Due to the implementation of the YOLO, YOLO requires that the size will be a multiple of 32. So here I'm changing the image to just crop it a little bit so that it can be accepted by the YOLO network. You can see that my editing skills are kind of terrible because it's my first video, but thank you very much for watching, especially if you reach this place, and I hope you have a great day.